Hi, everyone. My name is Jayshree Sarathy, and I'm excited to be here with you today to talk about our work called Don't Look at the Data, How Differential Privacy Reconfigures the Practices of Data Science. This is joint work with Sophia, Audrey, Haque, Tania, and Salil, Vadhan. Over the last 2 decades, we've seen growing threats to the privacy of data subjects, both in the theoretical literature, but also in real-world attacks on sensitive data. We've also seen that heuristic approaches to privacy, such as removing PII, do not protect against re-identification and reconstruction attacks on this sensitive data. At the same time, there's a push towards open access to government and research datasets for public use, as you can see through the proliferation of open data archives, such as Dataverse, and federal initiatives to make research more freely available. One promising solution is a technical notion that emerged to address these threats in a rigorous manner called differential privacy, which is a technical framework that involves adding carefully calibrated noise to statistical releases. It also offers additional guarantees and desirable properties such as transparency of noise addition, provable guarantees around privacy, and now there's a growing suite of algorithms, software libraries, and toolkits to facilitate implementation of differential privacy in different settings. However, we've seen over the last decade that many deployments show unaddressed gaps between the theoretical framework of differential privacy and social and contextual factors of data science in practice. For example, social scientists have had difficulty integrating differential privacy into their workflows. In addition, we saw during the 2020 US Census that the adoption of differential privacy sparked controversy and anxiety around the use of this technique in critical public data processes. In this work, we explore the challenges and opportunities when using differential privacy for data science. Recent work has explored some of these challenges from the perspective of data subjects and developers of differential privacy software, but less studied are the perspectives of data practitioners, such as data providers, also called custodians or depositors, and data analysts. Data depositors collect data from data subjects or curate by linking from different sources to produce a data set with sensitive attributes. In the open data framework, they upload this data to an archive such as Dataverse that allows it to be accessed by other researchers and the public. Typically, analysts have to go through lengthy and costly application processes to get access to the raw data. But with differential privacy, they can access the differentially private statistics released by the depositor and even interactively query the interface for additional privacy-preserving statistics. The interface we use is called DP Creator, which is powered by the OpenDP open source software library. And my co-authors and I have been involved in the design and evaluation of DP Creator. This interface aims to make it easy for non-experts in differential privacy to reap the benefits of privacy-preserving data sharing and analysis. It has 3 main interfaces: depositor, analyst, and administrator. And here's a display of the depositor landing page, which prompts the depositor to review requirements, connect a data set, work on a differential privacy release, and then submit it. The research questions we consider in this work include: what barriers do data practitioners face when using differential privacy to share or analyze sensitive data sets? What do data practitioners perceive to be the potential utility of differential privacy for its stated use cases, including expanding access of sensitive data to the public, facilitating exploratory data analysis, and enabling replication of scientific studies? What are the implications of privacy-preserving data science for privacy-preserving data science in terms of ethical, epistemic, research, and design implications? To consider these questions, we conducted a semi-structured interview process with 19 data practitioners who are non-experts in differential privacy, but experienced in sharing and analyzing sensitive data sets within the context of research data repositories. We sorted the participants into the roles of data depositor or analyst based on their background, skills, and experience. And then we observed as they used the DP Creator prototype to release statistics. And we had them talk aloud as they were going through the process to understand the challenges and perceptions that they had during this process. Then we conducted thematic analysis and mapped what we found from the perspective of participants onto the data science workflow proposed by Philip Guo to identify tensions and areas for further research. Guo's workflow includes 4 stages: preparation, iterative analysis and reflection, and then dissemination. Our participants, especially on the data analyst side, also went through these stages when trying to analyze differentially private statistics about sensitive data sets. We mapped many challenges that they faced across these different stages, but I'm going to talk about a few of the most common challenges across all of our participants. First, in the preparation stage, analysts found it difficult to clean data and check assumptions through the interface because they didn't have access to the raw data anymore. The interface asks users to choose metadata parameters for variables, such as ranges for numerical variables that depend on the data domain, but not the data set itself. And this is really important for use of differential privacy algorithms. But analysts found it difficult to do so, first because they didn't have access to the raw data, but also because this was not part of their regular practice of data science. In the reflection stage, participants found it hard to interpret accuracy guarantees given to them by the tool. For example, that the noise added for a certain statistic was going to be less than a certain value with high probability. And it was hard to interpret this without full context of the data, such as the size of the data or distribution of different variables in the data. This was just a small sample of the challenges that we mapped, but overall we found that differential privacy significantly challenges and changes every step of the data science workflow. This means it will take some reconfiguring of data science practices in order to integrate differential privacy. Now, what are the ethical and epistemic implications of reconfiguring the practices of data science? First, we found that differential privacy does offer wider access to the public of some insights of sensitive data, but for more experienced data analysis, it complicates this process of data exploration. Second, differential privacy constrains the user towards having only certain interactions with the data through the interface. And this is good in some ways in terms of privacy and generalizability, but it also constrains the judgment of the data analyst and replaces human interaction with black box manipulation. And this really changes the way that knowledge may be produced with data science. And it also requires new forms of expertise to work with the constraints of differential privacy. Finally, by constraining users, the tool might protect against privacy attacks and tendencies towards overfitting to the data. But also data analysts may be missing problems in the data or maybe making poor assumptions about the data. And this poses questions around trust in the findings that we get from differentially private data analysis. We end with providing suggestions for design and research of differentially private data analysis. And I'm just going to breeze through this without going into detail. But the first thing is to provide better guidance around setting parameters and making decisions. Second, we need better workflows around trust and safety, both for data practitioners who are doing the analysis, but also for the data subjects they are trying to protect. And finally, having better features for automated or depositor-led contextualization of the data. So synthetic data generation for checking assumptions about the data, but also better data set annotation, as we see through the literature on transparency and bias mitigation through data sheets for data sets or model cards. We need better releases of different aspects of the data that can help data analysts contextualize their findings. In conclusion, this work explores how data practitioners engage with interfaces for privacy-preserving data analysis in order to highlight challenges and opportunities for integrating differential privacy into data science workflows. In the future, we hope to provide and see more research into educational resources for data practitioners, as well as tools for annotation, parameter selection, budgeting, and analysis more broadly. Thank you so much. Here's a link to the paper and my email, and I'm looking forward to discussion and questions.